Alright, I want to talk about some imaginary numbers to finish up these notes. And we've talked about pure imaginary. And just to review, I squared is defined as a negative 1. And so I is, oh, I forgot my squared. So I is defined as the square root of a negative 1. Alright, so we're going to have something called a complex number. And a complex number has two parts. It has a real part, which means a member of the real numbers, plus an imaginary part, an imaginary, like an I. So if I have something 5 plus 3i, this would be the imaginary part, and this would be the real part. Okay? And what you find out is the reals and the imaginaries make up complex numbers. So if I have 7, just the plain old 7, I can say that is 7 plus 0i. Okay, so it's a complex number because it has a real part and it has an imaginary part. Likewise, if I have 5i, I can say that's 0 because 0 is a real number, plus 5i, there's my imaginary part. So all numbers fall under complex numbers, and a complex number has two parts, a real part and an imaginary part. I can write reals in the form of a complex number, and I can write imaginaries in a form of a complex number. Okay, so that's how a complex number is defined. And then I want to take a look at something like this. I want to take a look at something like 3 over, we'll start easy. We'll say 1 plus I. Alright? This is not in simplest form. And the reason it's not in simplest form is because this I is viewed as something inside a rational, inside a radical, inside a square root. And so anytime you have a complex number in a fraction that's in the denominator, it is not considered to be simplified. So what we do is we simplify it, and we simplify it by this idea of multiplying by the conjugate. And the conjugate, it's the same thing, but what's different is if I have adding, I'm subtracting. If I'm subtracting, I'm adding. I have these opposites. And I'm going to multiply the top and the bottom by that conjugate. So what I have here, on the top, I'm going to have 3 times 1 minus I. And on the bottom, what's nice about multiplying conjugates, because if you do FOIL, the inner and the outer, if I FOIL this, I'll get I'll get 1 minus I plus I minus I squared. Okay, so this, every time you multiply conjugates, this always happens. Those two inner parts are opposites. And so what I'm left with now is I'm simply left with the first and the outer anytime you have conjugates. Just the 1 times the 1 and the I times the I, and it's always minus I squared. So this is what it looks like. And what's cool about this is I get 3 minus 3i if I distribute on top, and down here I'll have 1 minus a negative 1. So I get 3 minus 3i over 2. And now I've simplified this complex fraction. Let me give you another one. I'm going to do 2 plus I on top, and the bottom I'm going to have 4 minus I. Now the bottom is always what determines what I'm multiplying it by, and so I'm going to multiply by the conjugate, 4 plus I. And over here on the bottom, again, I just have to worry about multiplying the outside, so I'm just going to take 4 times 4, which is 16, minus I times I, which is I squared. And then the top I'm going to have to FOIL. Here's my outer, which is 8, my inner, which is 2i, my outer, which is 2i, my inner, which is 4i, and my last is going to be plus I squared. Okay, first, outer, inner, last. Down here on the bottom, I get 16 minus a negative 1. And up here I'll get 8 plus 6i minus 1. So my final answer is 7 plus 6i. Notice I write it in complex form over 17. Now I'm perfectly happy with this. You're going to see the book is going to write it like this. 7 over 17 plus 6 over 17i, because that is truly in complex form when you have a real part and where you have an imaginary part. Alright, I'm going to do one more. And I'm going to have 2 plus 3i over 3 minus 5i. Okay, so now I'm going to multiply again by the conjugate, which is 3 plus 5i. Remember, the denominator determines what you're multiplying by. Both the top and the bottom get multiplied by that conjugate. Always, always, always. On the bottom. Now, I'm only going to worry about 3 times 3, which is 9, and 5i times 5i. And I have minus 25, because 5 times 5 is 25, I squared. And on top I'm going to FOIL, and I'm going to FOIL mentally. 2 times 3 is 6. The outside is 2 times 5i, which is 10i. The inside is 3i times 3, which is 9i. And the last is 3 times 5, which is 15. I times I, which is I squared. And so that's what those are my multiplication. Down here I'm going to have 9 minus a negative 25. Notice that'll always be negative. And over here I'm going to have, well, this is going to be 6, and this is going to be a negative 15. And 6 minus 15 is a negative 9 plus 19i. So my final answer is a negative 9 plus 19i over 34. Now, the book may give you this fraction plus 19 over 34i. If they do, don't freak out. See you tomorrow.